Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello, and welcome to podcast number 3. A wonderful number is 3, according to Pythagoras and the Pythagorean school. The number 3, which they call triad, is the noblest of all digits, as it is the only number to equal the sum of all the terms below it. Anyway, this brings you up to date with the happenings for the beginning of October 2014 on Transum Mathematics. So we'll start with the puzzle of the month for you to think about as you drive, cycle, jog, or do the housework, or whatever you do while you're listening to this podcast. October brings autumnal colour to the northern hemisphere while welcoming warmer weather to those down under. The highlight for some is Halloween, which comes at the end of the month and comes with spooky themes, trick-or-treaters, and pumpkin lanterns. So the puzzle of the month, this month, is for Halloween. And it is, why do mathematicians think that Halloween is the same as Christmas? I think most people would need a clue, because this is quite a tricky puzzle. So I'll let you know that the answer is something to do with number bases. Actually, I think the study of number bases could have a bigger part to play in the mathematics curriculum. My feeling is that it would strengthen the understanding of place value, times tables, and number patterns, which are all essential concepts of basic numeracy. At one stage in my teaching career, we successfully ran a number bases topic as the transition between primary and secondary schools. It led to some great problem solving, investigations, and display work. Two things that stick in my mind are the excitement of meeting the binary system, and you can see that in action on the Transum website. Look at the coins in envelopes starter, that leads to the binary the system, and look at binary lights as well. And the discussion about why having 5 fingers on each hand played a big part in us adopting base 10 as our standard. There's a very interesting video about the 4-fingered world of The Simpsons called Pi and 4 Fingers, and you can access that via the Transum website too. So, last month's updates. What's been going on? What's changed? What's been added? Well, the following pages were updated: the standard form online exercise, the Venn diagrams pairs game, sign sequences starter, the rounding online exercise, the missing pound starter, and the Thai restaurant quiz. A new activity, brand new, called Polygon Properties has been added, and the object is to join the names of the polygons with their properties. Now this is a many-to-many relationship, and the finished product can look very busy. So doing the task in a systematic manner is essential if you want to be sure you don't miss any links. Four's Independence is a new starter for the 4th of July, American Independence Day. It's a variation of the 4 fours challenge, presented as the numbers on a clock face. So each number has been expressed using 4 number 4s, if you see what I mean. Apologies if there's a bit too much red, white and blue on that page, but it is the 4th of July after all. No Way is a new version of the 18th of June starter, which previously provided 4 divisions to be evaluated. The new version is more visual, though requiring the same calculations to be performed. Finally, the Number Skills Inventory was unleashed on the world. It's a grid showing the basic numeracy skills that we expect pupils to develop at some time in their learning journey. The main motivation for creating this inventory grid was to produce something that provided visual impact. Each of the ideas or concept has been broken down into 5 levels. This has been done for consistency, so the differences in the difficulty between the levels is not the same in all cases. My feeling is that it will be most useful when you're working one-to-one with a pupil. Each of the statements has an example generated using random numbers, so they're different each time, and they will help identify if the pupil is confident at that level or not. And there are also links from each statement to an activity on the Transom website, so that if the pupil is just learning a concept for the first time, there's somewhere for them to practice. Also on the grid, you can very easily, just by ticking the boxes, record what the pupil has mastered. And the recording is remembered by your browser using something called HTML5 local storage. So the data is stored on your local computer rather than being sent to some remote server. We welcome new subscribers this month from the UK, the US, Dubai, Kuwait, China, Singapore, and Ireland. You're all very welcome.
You are listening to the Transom podcast. You can find Transom Mathematics at www.transom.org.
As usual, a number of people have sent in comments and observations on various pages. On the subject of the broken calculator, Ermin Primary Academy from England says that Class 11 solved the problem together. Well, that's just perfect. I mean, these starters are designed to be projected on a big screen at the front of the classroom, and they just lend themselves for everybody working together on a problem, chipping in, sharing ideas, and coming up with a joint solution. The exponential error starter, one of my favorites, Josh Han from King's, Worcester, said, "Excellent, well done. The more of these, the better." Well, that's very good, and you have to go and see that starter to see why he thinks it's very good. There's a little twist in the tail, let's say. On the subject of the Love Math Starter, Pippa Tyler from Beaminster School, Dorset, says, "I set this activity with my Year 10 Set 4 and Year 11 Set 1. They both loved it. The Year 10 class found about half of the words with no help, but Year 11 found all 9 and had great fun trying to unravel the anagram with some interesting names produced. They did succeed in finding the famous mathematician, and then we spent some time finding out what he had done for maths. A really different starter. Please can we have more like this?" Well, that's really good to hear how different people are enjoying the different styles of starter. They're meant to be quite different so that your maths lessons have a lot of variety and it doesn't become a boring routine ritual. So we're glad you like the variety. On the subject of the multiplication grid starter, MAP from MAP says, "Just noticed a reply to my comment from last year." So last year, this person, MAP, had requested more levels in the multiplication grid, so they have been added. He says, "Thanks for this. To make it perfect though, could we have a negative positive version of level 1.5? Well, ever eager to please, Transom tries to, in response to the comments, provide you with the functionality that you need. So a reward for your comment was the production of that facility. The how many triangles, well, the number one, the how many triangles number 1 starter, someone from Kuwait says, "I see 27, but maybe I'm wrong. I've been looking at it for days and still see 27. In the middle there is a 3x3 shape that could be considered a triangle, but if it is, it does not comply to the general patterns. You know, these how many triangles and how many rectangles starters seem to generate more comments than all the other starters put together. They're extremely popular. Maybe they're picked up on the Google search engine, but lots of people come along and leave their comments. Very popular starters. On the subject of the broken calculator starter, Mr. John Smith from LC32, whatever that is, says, "We did it in 15 moves. Now who can beat that?" Exclamation mark and 2 question marks. So there's a challenge, 15 moves. According to Mr. John Smith, can you beat that? Broken calculator starter. On the subject of the flowchart starter, David from Illinois says that this is an employment of the Collatz conjecture. Well, I'd never heard of the Collatz conjecture actually, but quickly looking it up on Wikipedia, found out that basically any number plugged into this flowchart on this starter will eventually end at 1. And he does put in brackets, save for a few. Wonder what those few are. On the subject of the number in words starter, AW from Worldly Knowledge says, definitely say point for point, not and. Now that probably won't mean much to you, but it's in response to the very first comment that was made on this starter from 8th grade class, Waverley Junior High. And they say you should not use and in writing numbers. And stands for the decimal point. Now, couldn't quite understand this, but doing a little bit of research. In fact, there's one website, grammophobia.com, and they say that our posting mentioned a child who lost a multiplication bee because she answered that 12 times 11 was 132. The correct answer, according to the contest sponsors, was 132. So she was penalised for using the and. Apparently, in certain areas, parts of the world, they use and in numbers to stand for the decimal point. Now, the Oxford English Dictionary explains that and in numbers is frequently omitted colloquially in North America. This implies that including and is the more standard usage, while omitting it is an informal or conversational usage. But we don't know where the misconception that and means a decimal point came from, but unfortunately it's all over the internet, and apparently elementary school teachers are even passing it on to their students. Okay, the answer to the puzzle for this month. Quite a strange one this really, but it was to do with number bases. And the answer to the puzzle, why is Halloween the same as Christmas, is to do with the dates and reading the dates as number bases. So if you think of the equation 31 oct equals 25 dec, I mean that gives the impression that 31st of October is equal to the 25th of December, but written in that abbreviated form, it could also be interpreted as 31 in octal or base 8 is equal to 25 as a decimal, in base 10. So 31 in base 8 is equal to 25 in base 10, and that gives you 31st of oct, or 31 oct, is equal to 25 dec. I bet you didn't get that, did you? Wow. Enjoy October. Oh, and don't forget, if you divide the circumference of a jack-o'-lantern by its diameter, you'll get pumpkin pie.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transum subscriber.